Good morning. Today's presentation is on graphing systems of inequalities. So the first step is get the equations in the form y equals mx plus b. The second step is to use the slope and y-intercept to graph the first line. Step 3, test points on either side of the line to see which makes the inequality true and shade, or get y on the left, and if it is greater than, shade up, and if it's less than, shade down. Step 4, use the slope and y-intercept to graph the second line. Step 5, test the points on either side of the line to see which makes the inequality true and shade, or you can get y on the left, and if it is greater than, shade up, and if it is less than, shade down. So let's go ahead and go over an example. Our first step is to get the equations in the form y equals mx plus b. Note that in this example, that's already done. So let's move on to step 2. We're going to use the slope and y-intercept to graph the first line. Okay. Please note that I have a dotted line, and the reason for the dotted line is that it cannot be equal to. So once again, it cannot be equal to. Please note the way that I graphed this as well is I knew my b, or my y-intercept, was 3. So I went up 3, and then I've got a slope, or an m, of -2. So I went down 2 and +1, or you can go up 2 and -1. Okay, if you're having problems with the graphing part, please go back and watch my recordings on how to graph a line in the form y equals mx plus b, and then come back and watch this video. Okay, let's go on to step 3. So we can test points on either side of the line to see which makes the inequality true, and then shade. Note that I personally only test one point, and then if it's false, I don't shade the point, and if it's true, I do shade the point. So I'm going to show you how I do it, but note that you can test points on either side until you find which ones is true if you would prefer that way. That'll make more sense in a minute. So I'm going to choose the easiest point. And to me, the easiest point is 0, 0. So I'm going to take my equation that I have graphed, y is greater than -2x plus 3, and I'm going to plug in 0 for y and 0 for x. Once again, that's because I chose the point 0, 0. So I get 0 is greater than -2 times 0 plus 3. Then I'm going to go ahead and solve that right-hand side. -2 times 0 is 0, plus 3 is 3. 0 is greater than 3. Is that true or is that false? Okay, please note if you're struggling with the greater than or equal to part, draw a Pac-Man. And the greater than sign is its mouth. Is the Pac-Man eating the bigger number? Because he's really hungry and he always wants to eat the bigger number. So if the Pac-Man is eating the bigger number, then it's true. If he's not, then it's false. So in this case, 0 is not greater than 3, so it's false. So we know the point 0, 0 cannot be shaded. So we know we're going to shade one side of our line. So because the point 0, 0 is false and cannot be shaded, we're going to have to shade the right-hand side of the line. Okay, or since we have our y on the left, please note this only works when y is on the left. Students all the time have the y on the right and try and do this and you'll get it wrong. So please make sure your y is on the left. Then we can go to our y-axis, or where our line crosses our y-axis at our y-intercept, and we can look for where y values increase or are greater than. Okay, so it's going to be there at the top. So we want y values are greater or are increasing. So we know that side of our line is shaded. Once again, please note that we have a dotted line because it cannot be equal to any part of that line. None of the coordinates for that line are going to work in our equation. Okay, let's go ahead to step 4. we want to use the slope and y-intercept to graph the second line. So once again, our y-intercept is 5 and our slope is 3, so we're going to rise 3 and run 1. And note that we have a solid line because it can be equal to. Now we're going to go ahead and test our points on this one. So once again, you can test points on either side of the line until you find which one's true and shade that side, or you can do like I do and only test one point. So once again, I'm going to pick the point 0, 0 because it's the easiest. So I take 3 is less than or equal to 3x plus 5. Plug in 0 for y and 0 for x. 3 times 0 is 0 plus 5 is 5. So I get 0 is less than or equal to 5. And once again, if you're struggling with how to read that, go ahead and draw in your Pac-Man. It's eating the 5, so 5 is the bigger number. Is that true? Yes, it is true. So we know the point 0, 0 has to be shaded. So once again, the point 0, 0 has to be shaded. So because 0, 0 has to be shaded, we know we're going to shade our right hand side of our line. Or if you're using the other technique, you can get y on the left, and then we want to look at the y-intercept and find, in this case, where y is less than, so where the y values are going down. So it's going to be that bottom half there. So it's going to be, once again, in our right-hand side of our line that we're going to shade. Then once we've graphed both of our equations, we can put them on the same graph and note in the online learning center that it'll automatically put it on the same graph. I just separated them to make it easier for you to visualize. But when you put them together, you'll get this purple region. So all possible solutions for the system of inequalities are found in that purple region. So once again, in the online learning center, I think they make them gray. I made mine blue and red so that you could see where they overlap. So once again, all our possible solutions are that purple region, or the region that is double shaded. The blue region is only coordinate points that'll work in our top equation. The red section is only points that'll work on our bottom equation, and the white section is all points that won't work in either equation. But once again, we want to focus on the purple one because that's coordinate points that will solve both equations, and thus will solve our system. Okay, let's try another example. So step 1, get the equations in the form y equals mx plus b. So note that that first one is already in the correct form, but the second one we need to solve for y to get it in the form y equals mx plus b. So I'm going to just drop down my equation, and we want to get y by itself, so we've got to get rid of the 3x and the 5. So which one's further away? Well, the 3x is, so we want to move the 3x to the other side. What's it doing to the y? Is it adding, subtracting, multiplying, or dividing? It's adding. So the opposite of adding 3x to both sides is subtracting 3x. So we're going to subtract 3x from both sides. Remember what we do to one side of the equation, we also have to do to the other. 3x minus 3x is 0x's. 0 plus 5y is just 5y. Because remember, 0 plus anything is just anything. So 5y. And then on that other side, one of the most common mistakes that I see is students will do 5 minus 3x. Please note that you cannot subtract those. So they end up with 2x when they do that, or they'll end up with a 2. But please note those are not like terms because the 3 has an x on it and the 5 does not. So we cannot add or subtract unlike terms. Therefore, we just need to write it out. Negative 3x plus 5. Please note you can also write 5 minus 3x, and that's the same thing. However, I like to put it in the form y equals mx plus b, so I write the negative 3x first. Okay, then we want to get y by itself, so we need to get rid of that 5. What's the 5 doing to the y? Adding, subtracting, multiplying, or dividing? Well, in this case, it's multiplying. The opposite of multiplication is division, so we're going to go ahead and divide both sides by 5. And when we do this, we get 5 divided by 5 is 1. 1 times y is just y. And then on the other side, remember we have to divide both the negative 3x and the 5 by 5. And the reason for that is the order of our operations. So please remember, when you're dividing something with a plus or a minus sign in between, you have to divide it into both terms. So once again, we have two terms with the negative 3x plus 5, so we've got to divide the 5 into both terms. So we take negative 3x and divide it by 5, which will give us negative 3/5 times x, plus 5 divided by 5 is 1. Now we've got it in the correct form. Let's go ahead and move on to step 2. Use the slope and y-intercept to graph the first line. Once again, if you need help with that, please view the other recording. Okay, step 3, we're going to go ahead and test our points. Once again, I only choose to test one point. You can choose any point. I'm going to choose the point 0, 0, just because it's easy. However, please note that if 0, 0 lies on your line, so that point lies on your line, you cannot choose 0, 0. And you're going to have to choose any point that is clearly on one side of the line or the other side of the line. So you could choose 1, 1, you could choose 1, 5, you could choose 3, 3, you could choose whatever point you want, as long as it's clearly on one side of the line. So I chose 0, 0 for this one because it does not lie on my line. And I went ahead and wrote down my equation, and I'm going to plug in 0 for y and 0 for x, and I get 3/5 times 0 is 0, minus 6 is negative 6, so 0 is less than or equal to negative 6. Is that a true or a false statement? Good, it's a false statement. 0 is not less than negative 6. You would rather have your bank account say 0 than negative 6. So therefore, because it's false, we know the point 0, 0 is not shaded. So we're going to shade the other side of our line, which is the right-hand side of our line. And once again, we can use our y on the left trick or way of solving. So we want to take y values that are less than, so I'm going to go to my y-intercept and look at values that are less than or getting smaller, so it's going to be that bottom half, and shade that. Please note that my line is solid because it can be equal to. Now I'm going to go ahead and use my slope and y-intercept to graph the second line. My slope is negative 3/5 and my y-intercept is 1. Once again, that's a dotted line. And the reason it's dotted is because it cannot be equal to. We just simply have a less than sign and not a less than or equal to. Okay, then we're going to go ahead and test our points. So I apologize, it's kind of hard to see, but 0, 0 is not on my line. So I'm going to choose the point 0, 0 again. So I get negative 3/5 times 0 is 0, plus 1 is 1. 0 is greater than or equal to 1. Is this true or false? This is false. So therefore we know the point 0, 0 is not shaded. So we're going to go ahead and shade that top half. If you're looking at y on the left and you see that y is bigger than or greater than, so we're going to go to our y-intercept and we're going to look for values greater than, which are all those values right there, and we know we shade that top half of our line. Now we've graphed our two equations, we go ahead and put them together. And once again, all possible solutions for the system of inequalities are found in the purple region. So if you really want to test it, once again, you can pick any of those points in that purple region and plug it into both equations, and it should work. If you did something wrong and you pick one of those points in the purple region and it doesn't work, then go back and rework the problem. Okay, let's go ahead and go over one more problem. So step 1, get the equations in y equals mx plus b form. So once again, the first one's already in the correct form. The second one we need to solve for y. So we need to move the 7x to the other side. The opposite of adding 7x is subtracting 7x from both sides. And we get 5y is less than negative 7x minus 5. Then we want to get rid of that 5. So the opposite of multiplying by 5 is dividing by 5. Divide both sides by 5 and we get y is less than negative 7 over 5x minus 1. Once again, remember to divide that 5 into the negative 7x and the negative 5. Then we use the slope and y-intercept to graph the first line. Okay, please note that my y-intercept is 4 and my slope is negative 7/5. And it's a dotted line. Sorry, that one actually should be solid. There's a mistake in my PowerPoint there. So note, because it's equal to, it should actually be solid. So once again, that line shouldn't be, the dotted line shouldn't be there. It should actually be solid. I think I got the two equations mixed up and saw the negatives or the equal to sign on that top one and the bottom instead of doing it on the bottom one. So note that that line should be solid. Test my point. 0, 0. So negative 7/5 times 0 plus 4 is 4. So 0 is less than or equal to 4, and that is a true statement. So we know that left-hand side of the line is going to be shaded because our point 0, 0 is shaded. Or we can look at the y on the left, and we know y values are less than, so it's going to be that bottom half. And there we go. Okay, use the slope and y-intercept to graph the second line. Once again, this one should be dotted. I got them mixed up. This one should be dotted. So once more, it cannot be equal to, so this one should be dotted versus the other one. I apologize for that. So we've got the point 0, 0, and we're going to go ahead and test it. So negative 7/5 times 0 is 0 minus 1 is negative 1. 0 is less than negative 1, and that is false, so we know that point 0, 0 will not be shaded. Or we can look at the y. We want y values less than, so it's going to be that bottom half. And we get our red portion there shaded. Okay, then we put the two together, and please note that I did do it correct here. The second line was the dotted line, and that first blue part should be a solid line. But the equations are wrong right there. So look at the equations right here. Okay, and once again, that purple region is where all the answers are found. Please message me if you need credit for watching this video. Thank you for watching, and I hope you have a great afternoon.